this physics. The first person who really attempted to measure the velocity of light was Galileo. And he did it in a very simple way. He put an assistant on a hill, Toscan Hill, a few kilometers away from him. Both had lamps, and Galileo was uncovering his lamp. And when the assistant was observing it, it uncovered his own lamp, and Galileo received the signal coming back, and he tried to measure the velocity of light from the delay. But of course, the only delay they found was the velocity of information in the brain. It was just the psychological time it took to find out that you detected something. And this experiment was, of course, unsuccessful because light goes much too fast for this kind of experiment to work. But, and this is a point I would like to stress, in physics or in science in general, things happen in a serendipitous way, in a way you cannot predict. And Galileo was, for another reason, very essential in the first measurement of the velocity of light because he invented the telescope. And so the telescope allowed him and others to observe planets and stars. And he observed the planet Jupiter and saw that Jupiter was surrounded by moons rotating around the planet. I am not sure, I don't know how Galileo saw Jupiter the first time, but this is the kind of picture you can take with an ordinary camera, a Canon or a Nikon camera. Just put it on a tripod. You use the zoom of the camera, and you get this kind of picture when you aim it at Jupiter, if you know where Jupiter is, of course, in the sky. So you see here 4 moons, and what happens is that these moons go behind Jupiter, so they are eclipsed by Jupiter, and then they come back. And astronomers, after the death of Galileo, have started to measure with precision the time at which the moons were coming back into vision. And one astronomer, a Danish guy, Rømer, working in Paris Observatory, used this measurement to make the first measurement of the velocity of light. In fact, Rømer measured the time at which the moon reappeared. And what he noticed is that the time of reappearance of the moons occurred earlier than predicted when the Earth was on this part of its trajectory around the sun. And it appeared after a longer delay when the Earth was on this part of the trajectory. And he attributed it rightly to the fact that during the time the satellite, the moon was occulted, the Earth was going closer or further apart from Jupiter, and so it took less or more time for the light to be observed. And he deduced from that a value for the velocity of light. But of course, this could be done only if you know what is the radius or the diameter of the Earth's orbit. And again, an important fact about science, discoveries occur when results coming from different fields merge. And at the end of the 17th century, one had a first idea about the size of the orbit of the Earth just by looking at the planet Mars from Paris and from Cayenne, which is in Guyana, and knowing the distance between Cayenne and Paris and the angle at which the planet occurred. By triangulation, it was possible to have an idea of the distance between the Earth and Mars. And knowing the laws of Kepler and Newton about the size of the orbits, it was possible to deduce from that a value of the diameter of the Earth. And this happened a few years before Rømer's work. And from that, Rømer deduced that light velocity is about 250,000 kilometers per second. He was very cautious because he knew that these measurements were crude estimates, but he gave the right order of magnitude. And it was clear from that on that Galileo could not succeed, because at this velocity, the time it took to go back and forth between these 2 points was microseconds, which you cannot measure.